Thank you for being here today. My name is Tadesse from Ethiopia, and I'm here today to talk about our work impacts of homophone normalization for Amharic natural language processing. For your information, Amharic is a Semitic language family and the second most widely spoken Semitic language after Arabic, and also serves as the official working language of the Federal Democratic Republic of Ethiopia. When we see the origins of Amharic language, its characters or alphabets are totally adopted from Giz language. Giz also classical Ethiopic language. And in Amharic or Giz language, there are different characters which have the same sound, but different in meaning and shape, which are called homophone characters. When you see the online community uses those homophone characters inconsistently. For example, in this standardized word, the first character sounds ha, it's a homophone character, and sounds ha or ha may be replaced by those other 6 types of ha sounds. To study the usages of homophone characters and the impacts of normalization, we have collected and analyzed around 5 million sentences, and we have built word-to-vec and fast text embedding models because the current research trend for Amharic NLP task is normalize those homophone characters into a single representation. So our last analysis shows that the usage of homophone character in Amharic text, especially in the online community, is inconsistent, and normalization has a negative impact on word embedding models. Our motive to do this work is to analyze Amharic web corpus in the usages of homophone characters, explore impacts of normalization on word embedding models, and lastly propose how to address the standardizations of Amharic language writing systems. When you see the objective, our work aims to explore the impacts of homophone character normalization, collecting a large general purpose dataset because Amharic language is a low resource language and there is no as much as this large data in the online, and lastly, to build different word embedding models. For this research purpose, we have collected text data from different publicly available sources, like from news, 2 million sentences, from web corpus or previously worked research, 1 million sentences, and from Twitter, 2 million sentences, and a total of 82 million tokens from 5 million sentences. And we have developed word-to-vec and fast text embedding representations using Gensim Python library and 200-dimensional vectors, because 200-dimensional vector is suggested by more researchers. And our approach seems like this. We have get input texts from different sources, and we have made a lot of pre-processing steps like text cleaning, tokenization, segmentation at word and sentence level, and normalization. And lastly, we have built fast text with CBOW and skipgram methods, word-to-vec with CBOW and skipgram models. For example, when we see top similar words that obtained from word-to-vec with CBOW method, before homophone normalization and after homophone normalization, the first two targeted words are different words that have the same meaning, and also the top 10 similar words that obtained from the word embedding is most similar to the target word. This shows that the word embedding, our word embedding model is quality. And the third and the fourth target words are homophone words, but they have different meaning according to the homophone character they contain. And also the top 10 similar words shows that those top 10 similar words shows that related to poverty, because this word meaning, the word meaning of this word is poverty, and the top 10 similar words of this word, that means salvage, are similar to salvage. After normalization, when we normalize those homophone characters into a single representation, we have missed the fourth target words, because homophone normalization is normalize those homophone characters into a single representation. So when we normalize, we have missed these words. We don't have get those words after normalization. So totally, when homophone normalization is applied inconsistently, the different meanings of words. For example, the third target word and the fourth target word will be transformed to this. That means poverty. This procedure means that the word with different homophone is eliminated for further processing. The TSNA graphical representation also shows that, for example, those three words are homophone words, but they have a different meaning, and also the graph shows that they are a little bit scattered because they have a different meaning, and also those three words are homophone words, but they have a different meaning, and also they are a little bit scattered. As a conclusion, this is the first work on the impacts of homophone normalization for Amharic texts, and we have collected web corpuses from different sources and analyzed. Our analysis shows that the online community does not follow the standardizations of Amharic writing style, and our developed word embedding models shows that normalizations of homophone characters has a negative impact, and normalizations has its own impact on word similarity. In the future, we have planned to study the effects of homophone character normalization on different semantic models that will be used by the current NLP research, such as named entity recognition, sentiment analysis, question and answering, and information retrieval. Our research outputs. Our research releases those outputs dataset, general purpose dataset around 82 million tokens, pre-trained models around 8 pre-trained models before normalization and after normalization, using word-to-vec and fast text embeddings and source code for the pre-processing, and the word embedding source codes are available through this contact. This is all about this work. Thank you.